Hugh Blackbar, I work at Thesis as well, and I've been asked to go through some of the challenges associated with renewable heat, and really my presentation is covering three things as a sort of a precursor to the Q&A. It's how did we get here, some of the current realities, and potentially where we are going. And it starts off with, I'm going to talk about how did we get here. Because really this is all about balancing a number of competing requirements which have recently become much more kind of interactive than they were historically. So heat load is one of the biggest energy demands in the UK. It's a lot bigger than electricity. And initially we had this heat load problem. We were asked to decarbonise it. And first of all, the route we went down was CHP to provide low zero carbon, respond to that low zero CO2 challenge. And that's been part of the sort of traditional solution, certainly applied in London and various other places around the country up to now. But since then, there's started then becoming a bit more of a focus as well on air quality. There's been the Medium Plant Combustion Directive. There have been 2 deaths now directly linked to air quality, both in South London. And there's been a lot of pressure coming on things like CHP and conventional combustion plants, which started meaning things were, there started being a sort of increased interest in heat pumps, which you'll probably see lots about in this conference. Meanwhile, elsewhere, according to another piece of legislation, the Montreal Protocol, specifically the Kigali amendments to the Montreal Protocol, there's been quite a lot of change going on in the refrigerant world. And as a result, the market is reacting to that. R410 and R134 have become much more expensive. They're both being phased out. So be aware of that, certainly if you're buying any heat pump equipment. And the replacements are not as simple. They have other additional concerns, safety concerns and things of that nature, which are manageable, but people aren't necessarily used to. Things associated with fire and DC regulations. R32 seems to be leading the way, but the future for R32 is also possibly, also has some uncertainty associated with it because it's still an HFC, and these amendments are all about phasing out gases with a global warming potential, of which R32 still is one. So that's meaning that the heat pump world is facing its own set of revolutions, and refrigeration in general is setting its own set of revolutions. But also, once you start dealing with heat pumps, you're crossing over into the world of electricity again. And electricity has also been going through its own revolution. There's been low zero carbon electricity happening. It's been happening a lot quicker than a lot of people forecast, and the carbon emissions are falling, which has also been increasing the interest in heat pumps. But all at the same time, we have got electrification of transport going on. Electrification of transport is far and away outstripping the heat pump world. There's now 200,000 electric vehicles, plug-in vehicles in the UK. We only had 20,000 heat pumps installed last year. They are causing a certain amount of problems, those electrification of vehicles, and they are sort of leading the way in developing some solutions to some of those problems, which are all around capacity constraints and things of that nature in the grid. But nonetheless, all combined with this low zero carbon electricity type of low carbon electricity numbers that are coming through, once again, people are talking about the electrification of heat, and that is quite a complicated subject, which we will go into in a bit more detail. Because if you're providing heat, we're also supposed to be providing this with low operational costs, low unit prices, and that applies to heat or electricity. Just look at the moment the press stories in terms of the price caps for electricity. There's similar things been going on in terms of calls for regulating heat in the world of district heating. So we're supposed to be doing this with low operational prices, low operational cost, low capex, everything's supposed to be done with low capex. And we've also still got the trilemma, which is security of supply, i.e. we can't have the electricity grid forever, and arguably people don't want their heating to be cut off either. These are all the competing requirements which have kind of led to where we are. And the question is, does something have to give? And that's something perhaps we'll come back to at the end of this talk. So that's kind of the setting of where we were. I'm going to now quickly talk about the current reality. And the current reality, especially when you get away from London, is in a lot of new development, is actually electric heating, direct electric heating, now being spurred on by the low carbon factors for the electricity supply. In fact, there are now certain storage heater and electric panel heater manufacturers now promoting their equipment as the low carbon heating solution, which is an interesting thing to do. So what I thought I'd do is I'll give you an idea of the current reality and a bit of a crude example of what impact this has for us and everyone else in terms of the electrical grid. Because when you come with a new connection, you go and ask for a new, you go and ask your DNO to provide you the load, the capacity to connect you all up. And what happens currently, broadly speaking, it's a little bit more complicated than this, is the new connection pays for certain elements. Now, it certainly pays for everything up to the point of connection. The new stuff that's going in, that has to go in because of it, it pays for it. It then has to pay a proportion of some of the other upgrades required. So, for example, if we've got a 10 MVA transformer here and we want another 2 MVA, then that might need to go up to, say, a 15 MVA transformer, because you can't necessarily buy a 12 MVA transformer. Maybe you can, but if it goes up to 15, for example, the developer pays, or the new connector pays something like 2/15 of the price. The other 13/15 of the price, and sort of proportions of any of the other upgrades that this is driving, get paid by the DNO. Furthermore, further up the grid, where there are things that are going on as a result of these capacity requirements, so maybe a transformer, several units away, or an interconnecting cable needs changing as a cumulative effect of all these connections, or because of just this connection. Again, that has to be done. The DNO pays for it. So, and under circumstances, the DNO pays for it. The new connection doesn't see the impact of that cost. Now, the DNO is a regulated organisation, which means it doesn't sit there and happily take a load of losses because a load of people want to connect to the national grid, to the local grid. What happens is the cost of those upgrades are returned to customers. They come back through fixed system charges that form components of your electricity bill. So the fixed component, the fixed charges in your building, in your bill, increase for both the existing customers and they also increase for the new customers as a result of this connection. And you end up with a scenario whereby electricity prices in real terms increase faster than inflation. In fact, the current government projections for rises in electricity prices in real terms, no inflation effects, no foreign exchange effects, no additional changes in policy, is between 12 and 24% for residences, residential customers, 24% for commercial customers. Why do you worry about commercial customers? Well, if you're a landlord or if the system is being run by a landlord, they're looking at the commercial rise, not the residential rise. Therefore, I will give you a prediction, which is that future renewable heat system selection is going to very much depend on the price of electricity and the price of electricity upgrades, particularly if there's no policy change. This is all pretty much dependent on the treatment of the gas network, because at the moment, without policy intervention, the gas network is almost certainly the cheapest way to go in terms of providing heat. I'm just going to share with you, because I've got limited time, you don't have to take my word for this. I would urge you to go and look at the National Infrastructure Committee report published in, I think it was July 2018, but it certainly looks into this, which quite neatly summarises a lot of the problems. The main message I want you to take away from this, they look at electrification through heat through heat pumps and through direct electric and various other things. If you look at the heat pumps, and if you can see that from back there, because it's a smaller screen than I anticipated, basically, between all of these are expensive. All of these are expensive ways of producing heat, much more expensive than the current system. Heat pumps cost almost as much as direct electric heating, with the costs being more towards the capital side, so purchasing the heat pumps and retrofitting insulation in any existing properties where you're putting heat pumps in. But they cost less to operate. Direct electric heating doesn't cost quite so much to put in, but it costs an awful lot more to operate. And these are some of the choices that we're going to be having to look at in the future. So do we save capital, do we pay in the operating costs, etc., etc. So some more predictions in terms of the future. Some stuff is going to be easy, we think is easier to predict in terms of where it may be going in terms of heat solutions. And they are the likes of offices, retail, hotels, things where there is already a cooling load. People are going to have to manage risks associated with refrigeration, manage refrigeration plant. Usually there's one person looking after that, and there are plenty of good reasons why those might go down a heat pump route. I've stuck schools in there as well, because schools are increasingly having very little new build schools are having less heating requirements. And the domestic hot water solution, that's actually more of a base load rather than a weather dependent solution. Weather dependent is where all the problems are in terms of electrical supply, and there's some options there. Basically depending on demand. As you get to larger demand, you may well look at other things. The less certain areas are things like housing, particularly the very interesting question of how much do you increase your energy efficient, increase your levels of fabric insulation before it's more cost effective to put in some form of a renewable heating system. There's an answer for that in Denmark. There's not yet really an answer been put out there for the UK. Other institutional accommodations and existing buildings which will remain the majority of building stock through to 2050. One of the key other problems, as I alluded to earlier on, is electrification of transport. All those costs that are up there, all the hundreds of billions that are there for electrification of heat, they all exclude the electrification of transport. And currently, as I said, transport is beating the electrification of heat hands down. That's particularly going to become a problem in places like actually rural areas, where the electrical network by its very nature is a lot weaker than in urban city centres. And finally, just end on some easy wins. Well, energy efficiency, there's a lot to be said for energy efficiency, but we would also argue there's some easier wins in terms of waste heat and district heating and things of that nature. But again, it comes down to some of the infrastructure costs and some of the policy drivers.